Hi, and welcome to Applied AI Series Part 3. In today's lecture, we are going to learn machine learning with regression analysis. And this is the part 1 of this lecture. In this part, you will learn what regression analysis is and how it works. So in the previous lecture, we discussed what machine learning is and the 3 types of machine learning. So we are going to now start with the machine learning models. So one of the fundamental models and the basic models that we learn in machine learning is the regression model. Let me remind you, this series is brought to you by Skills Zakhira. Okay, so regression analysis helps machine learning predict continuous values like predicting student marks, number of hours, price. So in most forecasting and prediction analysis, regression model is one of the most common models and the basic models that is used to make accurate predictions and forecast. So what is a regression model? A regression model helps us to make predictions based on the data that is already given to it. So it uses the already existing information, the stored data that we already know, to forecast what will happen based on that existing data. So a regression model finds relationship between the dependent variable, what we want to predict, and the one or more independent variable that we already know. For example, we know the number of months, and we want to know what the sale is going to be. The sales is going to be that is dependent on certain months. So we can make a relationship out of that. So we are going to dig deep into that later on. So don't worry, we are going to do more examples. It can find trends and pattern of a data. So this is one of the very important, what do you say, um, importance. One of the important things that a regression model does is that not only does it predict, but it can help us identify patterns. For example, the AQI level of air becomes worst in the months October, November, December. So it is predicting and identifying those areas, which helps us to identify uh, and make amends later on based on the predictions. So example, a very simple example to understand regression model is that we are predicting the height of a plant, okay, based on the amount of water. So giving water is an independent variable. We give water to all the plants that we have, and we measure the height of the water based on the amount of water, height of the plants based on the amount of water we have given. So in plant 1, I give less water. In plant 2, I give double the water. In plant 3, I give 3 times the water. And after an equal amount of time, I measure the heights. So this is going to help me make prediction of how amount of water is affecting the height of the plant. Other examples include predicting house prices based on area, temperature, based on area, marks for certain students based on their previous performance. There are many types of regression models. Some of the regression models are linear regression, when your independent variable and dependent variable are directly proportional. This usually gives a straight line in which the independent variable is plotted in the x-axis and the dependent variable is plotted in the y-axis, and we can see how the relationship works. And if we get a straight line, the data is linear. That is called linear regression. Many times, the data is not linear. When the relationship is curved and it follows a certain pattern, as you can see in the polynomial regression, that is called polynomial regression, where the relationship is not linear, but instead a curved. We can also have something called a multiple regression model, where we use more than one independent variable to determine an output. So there may be 3 factors, factor X1, X2, and X3, and these three factors are affecting the outcome of Y. So this is called multiple regression. In this part, we are only going to focus on linear regression. So let's understand what a linear regression is. Linear regression is the simplest form of regression. It assumes the relationship between the dependent and the independent variable is represented by a straight line. The equation of a straight line, you know, is y is equal to mx plus b, where x represents the value of the x-axis, b is the intercept, and m is the gradient. B is the y-intercept that cuts the line of the y-axis, and m is the slope or the gradient of the line. So this is the equation of a straight line, which many of you may already be familiar with. Real world example, as I just told you. So for example, if I am learning what the growth of a plant is based on the amount of water given, and I have a certain set of data. For example, if I give 1 liter water a day, 2 liters, 3 liters, and 4 liters, the growth in centimeter of plant becomes 2, 4, 6, 8. Now I want to predict what will happen if I give 5 liters of water based on the existing data. So I plot the graph and I see that there is a certain pattern it follows. So I'm going to draw that line with a straight line. The straight line is going to depict or show the pattern that it follows. Now, please note, every time you will not get all the points on the straight lines. The data may be scattered. In this case, we usually draw the best fit line. The slope represents how much dependent variable changes or each unit increases with the independent variable. So this is the formula of a slope. And you can simply, and we have already discussed what intercept B is, where it crosses the y-axis. So if the line crosses the y-axis at the value 0, B is going to be equal to 0. If it crosses at 1, it is going to be 1, and so on. So calculating the slope intercept of the plant growth. In the data set given, we can see we had 4 data points. So when we calculate the slope of that, we get 2. And when we calculate the intercept of that, we can see as the graph is directly proportional, it is passing directly through the origin or the center. So the B intersect is 0. So this equation of the line y is equal to mx plus b simplifies to y is equal to 2x. So every x value of um, water given of the liters of water given results in twice the growth in centimeters. So if I want to predict 5 liters of water, the predicted growth is going to be 10 centimeters. This is simple math that is applied to see the upcoming values. We can also find out how good our model is. Now, I have plotted these lines, but I want to see how previous data is, how accurate it is, how good the model is. Now, we have certain criteria to check if my regression model is actually working fine, if it is a good model, or if it is giving accurate results. So the first criteria to see is R squared. Second is mean absolute error. Third is mean squared error. And the fourth is root mean squared error, which is RMSE. We're going to discuss this more in the upcoming lectures. So stay tuned. This is just to give you an idea, a very basic idea for somebody who is not familiar with the regression model. Thank you for watching. Keep learning. We also have a part 2 for the regression model. So stay tuned for more updates. Like and subscribe so that we can update you on the next lecture as well. Thank you for watching.